Okay, this goes with my 8th physics lesson. This is a problem set where you combine vector components. By now you should have went through the lesson and have already worked these problems. If not, make sure you do the problems. I'm just going to walk you through them. I don't want to do them for you. So be sure to have a calculator and have done the problem. So let's go ahead and start with number 3. You have a vector that's 23 meters north and 68 meters north. Well, this one is not a 2D motion problem. So you're just going to have the first vector, draw the origin dot, draw the first vector, draw the second vector you see, and then all you're going to do is make north and north positive, so plus 68, plus 25, and when you put those together you're going to get plus 93. Well, plus stood for north, so the answer here is going to be 93 meters north. Okay, so now 2D motion, 43 meters east and 70 meters north, draw origin dot. We're just going to draw the first vector east first, and we're going to write 43 meters on it. And then we're going to follow that up head to tail with 70 meters north. Now we're going to go ahead and finish off the resultant, going back to the start, drawing the arrow from start to finish. These two arrows are going to butt up right over here, and we're going to throw the angle right there. And so now we're going to go ahead and go to our Pythagorean theorem to determine our C. We're going to put the sides, the non-hypotenuse sides in, square each of those, add them together, and take the square root of that, and we get 82.2 meters. That is going to be the 82.2 meters that's on the hypotenuse. And now we're ready to describe the angle. In order to describe the angle, you need to know which side's which. And this one right here is going to be the opposite because it opens up to that. And this one's going to be the adjacent because it's the side and it's not the hypotenuse side. So now we can go and plug in those values, 70 for the opposite, 43 for the adjacent. We solve for that and we get an angle right here of 58.4 degrees. So now we come up with our final answer. It's the magnitude, the 82.2 meters, 58.4 degrees. And then lastly, it's going to be, and I described this during my lesson, the baseline is what's coming out of, where the last thing that you write is going to be coming out of that origin dot. So it's north of the east. And so this would be the correct right answer. Once again, if you have east of north, make sure 90 minus your answer equals this, and that would be correct too. But if you have a different number here and you have north of east, then that's not going to be correct. Okay, the next one, 158 meters west and 40 meters south, origin dot. Once again, on your paper, place it so that you can go ahead and go west and south from there. Go west first, 158 meters. We're going to follow that head to tail with 40 meters south. And we're going to finish this off going from start to finish in the direction away from the origin dots. We go back to the start to the finish, throw the angle right there, and now we're ready to do the Pythagorean theorem and everything else. But for the second part, when we come up with the angle, this opens up to the opposite, and that is adjacent right here because that's not the hypotenuse. That's important for the next step. But to get this side right here, we're going to go ahead and take the 40 squared plus the 158 squared, and then we're going to take the square root of it, solving for C. Get 163 meters for our resultant right here. And if you're not getting, well, this one's fine, but if you're not getting the answers for your inverse tangents here, you want to make sure that you're still in degrees. If you're in radians, so you go to mode. If you're with a graphing calculator, if you don't have a graphing calculator, it's probably not going to matter. You probably won't be in radians ever. There's a way to do it, but you probably won't be doing it. And so this answer, when you put the inverse tangent, once again, this is inverse tangent. We saw in algebra how to break a tangent away from the angle. Tangent of an angle equals opposite of adjacent when we want to breaking that away. And so inverse tangent of 40 over 158. And you'll find inverse tangent usually like a shift or a second button to the tangent. Some calculators are weird. You have to search a little more for it, but you should get 14.2 degrees, and that's going to be this right here, 14.2 degrees. And now we're ready to come up with our overall answer, 163 meters, 14.2 degrees to the south of west. Once again, west arrow is coming out of the origin dot. So that's the baseline right there. So that answer, 163 meters, 14.2 degrees south of west, or you might have, was it 75.8? That's right, I think, yeah, 75.8 degrees west of south would be the alternative right answer. Okay, the next one, 60 meters south and 85 meters east. So we're going to go south out of it, and then we're going to go from the origin dot, draw the south, then go and draw the east, and then we're going to go ahead and go at the angle from start to finish, throw the origin dot there, and we go through Pythagorean theorem, but just so you, the second part, that's our opposite, that's our adjacent, because this opens up to this side, and this is not the hypotenuse, but it's at the side, so it's adjacent. Plug in our numbers, the 85 squared and the plus the 160 squared. Take the square root of that, you're going to get 104 meters per second. And then we're ready to go ahead and solve for the angle. And to solve for the angle, that's why the 85 should be over the 60. And we're going to get 55.4, so this ends up being 54.8 degrees. And now we're ready to come up with the final answer, 104 meters per second. There's our magnitude, 54.8 degrees. And then it's going to be to the east of south. Once again, out of the origin dot, always draw an origin dot, always draw arrows, and then you can kind of follow through the directions I'm giving you here. If you're not doing that, then it might be a little more difficult for you. Make sure that if you don't know what I'm talking about, go back to the lesson and listen to it. Okay, 92 meters per second north and 18 meters per second west. We'll go ahead and just follow the first direction. North first, 92 meters per second, then west, 18 meters per second. Start to finish, draw the angle right here after you drew the resultant start to finish. So back to the beginning to the end, angle there. And now this makes that the opposite. This makes that the adjacent because it opens up to this side right here. The opposite of this angle is 18 meters per second. So Pythagorean theorem, plugging in the values, 18 squared plus 92 squared. Take the square root of that. That gives you this side, which is 93.7 meters per second. Now we're ready to go ahead and solve for the angle. We're going to take the inverse tangent of the 18 over the 92, and we're going to get 11.1. So this would be 11.1 degrees right here. And now we're ready to describe it, 93.7 meters per second at 11.1 degree angle to the west of, take a look, north is coming out of the baseline. So the west right here of the north. Okay, so now we're going to go back and get some more practice. So if you're in CP, you're not going to have anything on the test harder than what we just covered. If you're in honors, you're going to also have these, but I do want all classes to get the extra practice, because if you get the practice at these, you'll be better at a bunch of different things, because you had to do our last unit lesson just to break that up. And so you have components of things we've done before, but test-wise, you won't get to this level in CP, but in honors you will. Once again, if you have my class, if you have a different class, you might do all of these. Okay, so we have 60 meters per second north. It's already a vector. It's already going to be a y component, but now we have to break this one into its x and y component. So I color coded these to kind of keep up with everything. We're going to draw this out. We're going to go east first, follow backwards, go south of east, and then go ahead and draw the resultant, or draw the angle in, which that's what happened here. Draw the resultant, 40 meters per second. If you ever have this number next to an angle, that is always going to be a hypotenuse. If you have something like this, it might not be a hypotenuse because it's just a component. But if you ever have an angle next to like a 40 meters or 40 meters per second, that will always be the hypotenuse. So you throw that on the hypotenuse, throw the angle next to the origin dot, and now you're ready to call the sides. This is going to be the x-axis, is going to be the adjacent or the side. This 20 opens up to the opposite, so that's going to be my y-axis component. And now we're ready to go ahead and solve for everything. So opposite is the sine of the angle, sine of 20 times the hypotenuse, and we're going to get 13.7 meters south as another y component. So it's not a bad idea to go ahead and write that in, 13.7 meters per second south. And we're going to go and do this to find out what this x-axis is going to be, cosine, because we're trying to find the adjacent side of 20 times 40, and we're going to get 37.6 meters east. So this is going to be 37.6 meters per second east. And so we can see what we're going to do here. The resultant vector is going to have only one x component, this 37.6, but then we're going to have to add this 60 north to this 13.7 south, which really is going to be a subtraction when we look at the math. So we're going to go ahead and call this positive 60. We're going to call that negative 13.7. We're going to put those together and we get a positive value, and the positive value is going to represent north. So the north is going to win out. This is a much bigger vector than that one, that 13.7. So it's going to win out, but now we have two solo vectors we're going to look at. Once again, This one was a vector of its own. This one we put together from that and that, adding vectors, but also taking into account signs. That leads us to this part. I went ahead and put my x-axis vector first because I said I was going to just always draw them out with the x first when we got to the more difficult components like this. And so draw them out. We'll go east first, 37.6. Go north from there, 46.3. Head to tail once again. We're not going back to the origin. We're starting from the last arrow tip, the head to the tail of the new one. Draw the resultant, draw the angle, and then we're ready to solve. But once again, this angle makes that the opposite. This is the adjacent, which is important for your inverse tangent. So we plug in our sides, 46.3 squared, 37.6 squared. We add those two together, take the square root of it, and we're going to get 59.6 meters per second. Let's get meters per second because we were given meters per second in the question in the first place. Now we want to find the angle right here. We're going to go ahead and take the opposite, 46.3, inverse tangent of 46.3 over the 37.6. And we'll get 50.9 degrees. So this is going to end up being 50.9 degrees. And now we're ready to go ahead and describe the final answer. So it's 59.6 meters per second, 50.9 degrees. And this one is going to be to the north of, once again, the baseline is going to be the last thing you see here, the east. This is the east direction. So we're going to the north of that east. And so this is the final answer for that problem. Keep on getting some practice. This one's going to have a single north component right there, but then it's going to have this other component that has to be broken into its x and y pieces. Once again, you know that because it has an angle next to the magnitude. So we're going to draw it out, go backwards, east first, then we're going to go north from that east, then we're going to go ahead and finish it off. Put the 25 meters per second on the hypotenuse, put the 40 closest to the origin dot. That's why we draw the origin dots, to help us give a structure to how we do things. We're going to go ahead and call that the opposite, and that is the y-axis because it goes up and down. In fact, it goes north, it goes up, but the y-axis itself goes up and down. And then we also have the adjacent, which is going to be the x-axis. In this case, it's going to be east because the arrow is facing east. So it's very important to draw out the arrows. But it'll never contradict this. We're never going to have an axis or a vector that's going west or south if this says north, or west if this says east. It's always going to be a north and east of that. So now we're going to go ahead and we're going to solve for our opposite side, our y-axis, that's going to combine with this 92 meters per second north. Plug in our values, sine of 40 times the 25. It's going to give you 16.1 meters per second north. So we know that we're going to have to add these two later on because they're both north, they're both the same direction, and it's going to be north. But let's go ahead and find the single, and this problem's only going to have a single x-axis. The cosine to get the side, it's going to be cosine angle of the adjacent over hypotenuse, which leads you to this. Cosine of 40 times 25, we're going to get 19.2 meters per second east. So we're going to have one vector going east, and then these two added together will be one large north vector. Okay, so then we have to make this, since it's north, positive 16.1, that's positive 92 meters per second. We add them together, we get a positive value. That positive value meant north in the first place. So now we have two vectors we're going to work with. We're going to have 19.2 meters per second east, and then we're going to have 108 meters per second north. We took into account everything else. Now we're just working with these. We're going to go ahead and do our x-axis first. Once again, because I'm just doing it every single time, x-axis first, but they both would be right answers if I did this first. It just would be a different right answer. So 19.2 meters per second, follow that up with 108 meters per second, draw the resultant, draw the angle closest to the origin dot, determine what the sides are because of that. This is going to be your opposite, this is going to be your adjacent, and then just like clockwork, we're going to go back to what we've been doing. Back to a normal problem, Pythagorean theorem to get the 108 squared plus 19.2 squared, square root of that, you get 109, that's going to be the hypotenuse. Now we're ready to do the inverse tangent of it. We have our opposite being 108, so inverse tangent of 108 over 19.2, and you're going to expect a big angle. Just this is a much bigger side than that, and it's going to be 79.9 degrees. And now we're ready to get that final answer. So the magnitude, the angle, and the description of it, we're going to go ahead and the baseline was east. And you're going north of that east right there. Okay, so lastly, the hardest of the problems right here, where we have to break all the things down. Let's go ahead and make sure we can draw these different vectors out. So 88 meters directed 22 degrees north of east. Go east first, then go north from east, and then go ahead and finish off the, you can either draw the angle in, but I usually do this part first. Finish off the resultant, the hypotenuse, start to finish. So once again, arrow should butt in right here. Throw the 88 on the hypotenuse. Once again, it's 88 meters directed 20 degrees. It has that 20, if it has any debris, it's going to be a hypotenuse next to it. And we have that one drawn out. And then we just determine, well, when we get the straight ahead, the opposite, that's going to be the y-axis component, and that's going to be north. And the x-axis component is going to be our adjacent side. That's going to be directed to the east. So we do the same thing with the other one, south of east. So east first, then from there go south. From there, finish it off, throw the 41 on the hypotenuse, throw the 52. 52 is right here. It's closest to the origin dot, so it's not there, just to make sure you don't misinterpret that. The x-axis is going to be the adjacent in this case, and the y-axis is going to be the opposite. So now we have everything to solve for, and there's a whole lot more math. These problems take a long time, and one little mistake and you can mess up the whole problem. So that's why we usually don't give you that many in honors. You probably have one on the test, and then a bunch of smaller problems. So opposite to find the y component, so we're finding the y-axis right here. Take the sine of the 22 times the hypotenuse. We're going to get 33 meters north. So this is going to be 33 meters north. Once again, a good practice to just draw it out next to the triangles so that you can compare and put things together easier. To find the adjacent, we're going to take the cosine of that 22. We're going to get 81.6 meters east. So it's going to be to the east. So we're going to draw that one in right here. 81.6 meters east. So these two components are coming out of that triangle. After you get these two components, you can ignore the triangle altogether. These are just two components we're going to have to put together with the components from this triangle. So we're going to go ahead and find the opposite side so we can find the y. Once again, color coded to go with the blue over here, the y-axis over there. In this case, the y is going to be the opposite, so it's going to be a sine of 52 times the hypotenuse. You're going to get 32.3 meters south. So it's 32.3 meters south. And then we're going to find this x-axis, the cosine, because it's on the side, cosine angle, cosine 52 times the 41, and we're going to get 25.2 meters east. So this is going to be 25.2 meters this way. So if you take a look, you're going to have your x-axes adding together and both being east, but then the y-axes are going to contradict. So, and they're pretty close to each other. So this is going to be a weird problem where you have an answer that has almost no angle. So let's go ahead, let's add our y-axes first, and then we'll add our x-axes second. The more you label these things, probably the better when they get really long like this. So north, we're going to call that positive, plus 33, and we're going to put that with the negative 32, which is south. And we're going to go ahead and add those numbers up, and you get a positive value, and that positive stood for north, that one with north over here. And so you get 0.7 meters north being one vector. Once again, we just went and we put this one together with that one, and now we have that single vector. Now we're going to go ahead and take the y-axis vectors. These two are going together. 81 meters east, we're going to call east positive. We're going to call east positive over here. Of course, we can't contradict. We have to be the same. And now we're going to add those vectors, and we're going to get a larger positive number because they're in the same direction. And we get 106.8 meters east. And now we're finally going to go ahead and pretend like we're starting a new easy problem, and we're going to put the 0.7 meters north. Actually, I'm going to put this first, 106.8 meters east first, and then put that together with 0.7 meters north. So that's what we're going to do here. You finalize it, draw the east first, label it, draw the north second, a little tiny arrow because it's not much, this is not even to scale, it'll be much smaller than that. And then we go ahead and draw the resultant, throw where the angle is going to be. And so we are ready to solve for everything, and this makes this the opposite, this the adjacent, because the triangle opens up to this side right here. Plug in the values, 0.7 squared plus 106.8 squared, we're going to get a number very close to this. It's going to be 106.8 and then 0 something. So I rounded actually to this number, but this is definitely bigger, just not much bigger, and that's why it ends up looking the same way. We will have a small angle. It's almost 0, but we will have an angle. So we'll have our opposite side at 0.7, the adjacent side 106.8. When we take the inverse tangent, we're going to get something around 0.4 degrees. And so our final answer here is 106.8 meters, 0.4 degrees. And this one's going to be north of the east. Once again, the east is the baseline, north of east right there. So that's your final answer. Or once again, the complementary one, if you went ahead and did the north first and then the east, you would have had 90 or 80, 89.6 degrees east of north, but still 106.8 meters would be your magnitude. Okay, last problem, and then you finally can take a break. These ones are long. So we're going to break this down. We're going to draw it out east of north. We go east first, we go north second. And then we go ahead and finish it off, put the 52 inside closest to the origin dot, draw the hypotenuse out, that's going to be 35 meters. Now we have a triangle we can solve for the different components. In this case, the opposite is going to be the y component, the x-axis is going to be the adjacent side because of the way this opens up to the opposite, and it's not the hypotenuse. Now we do the same thing with this. Let's go ahead and draw it out. Go north first, then go west from north. Then finish it off by drawing a hypotenuse with 67 on it and taking that 47 and putting it closest to the origin dot. And now we're ready to do the math. What you're going to notice here is the adjacent is the x-axis. So watch out for this because the x-axis is not going to so directed 47 degrees north of A. I think I fix this up later. This is going to be the opposite, and this is going to be the y-axis, is going to be the adjacent. So I came back and fixed it up later. So let's go back and look at this, and then when we get to that, I think it should be fixed up. If not, I'm going to have to delete this part of the video and start over from this part. But let's try it again. So we're going to find the y side. The y side is going to be sine of 52 times 35. We get 27.6 meters north, and then our x-axis right here is going to be the adjacent side, so that's going to be cosine of 52 times 35, and we're going to get 21.5 meters east. And now let's see if I fix this up here. The adjacent is going to be the y-axis. Good. Yep, I did fix it up. So adjacent is going to be the y-axis right here, and we're going to have, because it's on the side, and so it's going to be cosine of 47 times the 67, and that's going to give you the side right here, which is going to be the side going north, and it's going to be 45.7 meters north. Then over here, we're going to have the opposite side, and so we find the opposite side, which is going to be, and once again going with this was a y-axis, this was a x-axis, this was a y-axis, this was a x-axis. So we're going to have to put the y-axis together and the x-axis together, and just like I said before, I should draw this in, 27.6 meters north, and this one was 21.5, we were looking 21.5 meters east. This helps us think about if we're adding or subtracting these vectors and when we get them. This was 45.7 meters north, so this was 45.7 meters north. So we can tell we're going to have to add those together. And then when you solve for this, the sine, you're going to get 49 meters west. So right here we go on west. And that is going to be right here, 49 meters, this direction. So you can see that these two are opposing each other. 49 is bigger, so I'd expect the answer to be west. You can kind of think through this with the picture when you draw it, but that's what we do here. So let's put the y-axis together. You're going to have north being plus 27.6, north over here being 40 plus 45.7. Put those together, and you're just going to get a bigger north because positive is a bigger positive, so it's even bigger north. But now when we deal with the x-axis, we're going to have east being positive, and we're going to have west being negative. So you have the plus 21 plus a minus, really minus 49. You're going to get a minus value. That minus is going to be west. And finally, this turns into a normal early beginning problem and we put those two vectors together, ignoring everything else, starting with a new vector, going off the x-axis just because that's what I'm doing, but you could do the north if you wanted to and still get the right answer. 27.5 meters west, followed by 73.3 meters north. Fill in the resultant, fill in the angle where it's going to be, determine that this is the opposite because it opens up to that. And this is the adjacent because it's not the hypotenuse and it's not the opposite. And now we have everything we need to do Pythagorean theorem. Throw in the numbers, 73.3 squared plus the 27.5 squared, take the square root of that, you're going to get 78.3. Always watch out if you have a much bigger number, like huge, usually you can tell you did something wrong. You might not have taken the square root of something. But 78.3 meters, that's going to be right here. And then we're going to solve for our angle. So it's going to be the opposite, which is 73.3 over the 27.5. And we're going to take the inverse tangent of that, and we're going to get 69.4. So now with 69.4 in here, we're ready to do the final answer. The magnitude is 78.3 meters, 69.4 degrees. And in this case, we are going out of the west. As a baseline, we're going north of west. And so this is your final answer, or the complementary would be 78.3 meters. It would be 20.6 degrees west of north would be right as well.